Okay, so this is the 4C handout. Um, and in this one, it starts out with a new theorem, the angle-angle side theorem. That's what the AAS stands for, angle-angle side. So it says if two angles, so like angle B here and angle C here, and a non-included side, so a side that's not between B and C in this problem, so something like AC of one triangle are congruent to those same corresponding parts in another triangle. So B goes with E, C goes with F, and then the non-included sides go together. And notice the non-included side is the one attached to the angle that has one curve. Same deal here. So if you have that angle-angle side sort of matching up between two triangles, then you can say the triangles have to be identical to each other. They're congruent. Okay, so up to this point, we've had SSS. If all three sides of one triangle are the same as all three sides of another, then the triangles are congruent. We've had SAS, where you match up two pairs of sides and the angle in between. We've had angle side angle. You match up two pairs of angles and a pair of sides in between the angles. And now we've got this one too, AAS, which, by the way, is really the same thing as SAA, right? Side angle angle. You could look at it as, we'll start with this side and then say, now I have this angle and that angle. Right, so it doesn't really matter to me if you call it AAS or SAA. Okay, so the question is to prove this. We've got GJ, that's this part, is the same as GK, that part. And angle H, this angle down here, is the same as angle I down there. And the goal is to prove that GHJ, which is this triangle, is the same as GIK, that triangle. So they overlap. So what I'm going to do is I'm going to draw the two triangles by themselves, the two ones that we're trying to prove. So there's GJH, which kind of looks like this. And then there's GKI, which looks like this. GKI. Okay. So we'll work our way through the proof and let's see what we got. So first statement, we'll do one of the givens. GJ is the same as congruent to GK. So that's given. All right, so in the diagram, I'm going to mark these two the same. Okay, well, the nice thing about that is this step all by itself already gives me a pair of sides matched up. And so I've got the S that I need. Okay, let's take a look at what else we know. We know angle H is congruent to angle I. So here's angle H, here's angle I. Those definitely match up because it's given. So that's given. By the way, if you wanted to cram all the givens into one step, that's fine. So this is a pair of angles that we've matched up. So now we've got an S and an A. The goal was to use AAS, so we need one more pair of angles matched up. Well, if you look at the diagram, notice this angle was the same in both triangles. It's exactly the same. This angle and this angle are equal to each other because they're identical. Right? So step 3, that second pair of angles that we can match up would be angle G is congruent to angle G. The angle G in this triangle is exactly the same as the angle G in that triangle. So anytime something equals itself, that's reflexive. So there's another pair of angles. Now these 3 steps could have gone in any order, right? It just happens to be SAA, but there's no reason that this step couldn't have gone first, right? Or this step, right? So let's see. If you look at the diagram, you have an angle, and a side not included in those 2 angles, not GH, right? So you have, whoops, hold on. You have angle side over here. You have the same angle side orientation over here where that side is attached to the 2 curves. Same thing here, side is attached to the 2 curves. So we have this criterion satisfied in order to say that 2 triangles are congruent. So now we can say for triangle GHJ GHJ. Let's see, GHJ goes 2 curves, 1 curve, no curve. So then this one would have to do the same thing. GIK. And the reason is angle, angle, side. Or side, angle, angle. Either one's fine. Okay, now what I want to do is I'm going to extend this one extra step. Now I realize that we're done with the proof. But if I said, what's anything else that we could determine from this, right? Let's try this one, right? One new thing, now that we know that triangles are identical, I can match up any corresponding parts that I want in those triangles and say that they're the same. So an extension could be something like, okay, well, let's match up this side and this side. Because now I know the triangles are identical, so I can match up corresponding parts. So that would be HJ goes with IK. Right, the last 2 letters here goes with the last 2 letters there. HJ congruent to IK. And the reason is because they're corresponding parts. Corresponding parts. They're corresponding parts of triangles that are already congruent. And the corresponding parts are congruent. Right? So we have congruent triangles. The corresponding parts in this case are HJ and IK, so they have to be the same. And if you want an abbreviation for that, that's CPCTC. Corresponding parts of congruent triangles are congruent. Okay, let's go on to number 2. So number 2 says, okay, we've got 4 ways to prove triangles are congruent. So there they are right there. And when we listed off on the last handout all of the different possible combinations of A's and S's, angles and sides, we ended up with these. Now these two are really the same. Here, I'll list them off together. Let's see, SSA and ASS. Yes, I realize what that says. Okay, but just so you know, you'll never actually see this one in a textbook. It always shows up as this instead. So these 2 things are really the same thing. Whoops, sorry about that. These 2 guys are really the same, just the same way that these 2 are the same in the previous problem. And we already figured out that a few of these guarantee congruent triangles if you can match up the pairs of stuff. SSS works, SAS works, ASA works. Whoops. AAA didn't work, right? Because it guaranteed that the triangles would be similar, but just because the 3 angles all match up doesn't mean that the triangles are exactly the same. Let's see, what else? And then we figured out that this one works too. In the previous problem, we said that that works too. So really the only one left to check is this one. And it turns out that this diagram right here helps us figure out if having 2 pairs of sides matched up and an angle not between them, so something like this, let's say. If you match up 2 pairs of sides, let's say I have another triangle right here, 2 pairs of sides, and an angle not in between them. So not this angle, right? But one that's not touching both sides. It's only touching one side. So like maybe this one. So if I can match it up with that one, am I guaranteed that these 2 triangles have to be congruent? So it turns out that this diagram helps us figure that out. And the way to do it is, well, consider there are 3 triangles in this picture. There's this small one right here, there's this small one right here, and then there's this large one. So what I'm going to do is I'm going to draw 2 of the 3. I'm going to draw ABD, which looks like this. And then I'm going to draw the big one, ACB. And some of the things that we know BD and BC are the same. So in this picture, that's this line and this line. But we know some other stuff is the same. AB is in both of these diagrams, so AB is the same too. So right now I've matched up 1 pair of sides, 2 pairs of sides. I have SS, right? And the 2 sides are touching each other, so they're right next to each other. And it turns out I also have another reflexive thing in this diagram. Angle A is the same in both angles. Let me use one curve. So this angle is the same in both. So I actually have a side, and an angle only touching one of those two sides that I know. So I actually have SSA in this diagram, and I have exactly the same side angle orientation in this diagram too. Well, if you look at the two triangles, they're definitely not the same. One of them is smaller than the other one. So SSA is not enough to determine the two triangles are congruent. So here, I'll write out kind of some instructions over here so you have notes that you can put down and reference later. So one of the things that we knew, BC was congruent to BD. That was given. We knew that AB was congruent to itself. That's reflexive. We knew angle A was congruent to itself. That's reflexive. So what we've done is we've matched up SSA, or if you wanted to call it ASS, that's fine with me, info, for both triangles. But the triangles, these triangles, are not identical to each other. They're not congruent. So we can't use SSA or ASS to prove triangles are congruent, because it's not guaranteed that they'll be congruent. You could end up with two different ones, right? So now we can cross off, oops, not that one, sorry. We can cross off these two, and it turns out that these are all of our reasons to prove that two triangles are congruent. So there's really four there. It's SSS, SAS, ASA, AAS, or SAA, depending on how you want to think about it. Okay. Let's move on to number 3. And then over here, I'll list off those reasons again. The ones that work for proving triangles are congruent. So there's SSS, there's SAS, there's ASA, and there's AAS slash SAA. I don't know what's going on with the marker here. There we go. Okay, so let's work on this proof. Okay, it says first aim to prove that the two small triangles are congruent, and then aim for this. All right, so let's start out with the given, and we'll start out with the first given here. 1 BA is perpendicular to YZ. So that's given. Okay, so BA is perpendicular to YZ, meaning these two angles have to both be 90. You could say, so angle 1 equals 90, angle 2 equals 90, and then get to angle 1 equals angle 2. That's fine doing it that way. So, in fact, I'll list it here. You could say measurement of angle 1 equals 90, and measurement of angle 2 equals 90. So that's because of definition of perpendicular lines. And then you could list these as two separate steps if you wanted to. And then since they're both 90, you can say measurement of 1 equals measurement of 2 because of substitution. Or you could just say angle 1 is congruent to angle 2 if you wanted to do that. So then if you look at these three steps together, they give us a pair of angles, right? Angle 1 and angle 2 matched up. Now, by the way, you could do these three steps in just 2. I'll kind of make a little note over here. Or just use this step. You could go straight to angle 1 is congruent to angle 2 because we've learned something that says if you have perpendicular lines, then they form congruent adjacent angles back in Unit 2. So you could have put this step here in place of these two steps if you wanted to. Doesn't matter to me how you approach it. If you see the 90s and then set those equal to each other better than you see this shortcut, that's totally fine. All right, so that's kind of one chunk of the proof here that gives us a pair of angles. Okay, so we're probably going to aim for 2, 3, or 4, right? Not 1, because 1 requires all pairs of sides. So we need something with a pair of angles in it. All right, let's take a look at our next given. BA bisects angle YBZ is given. Okay. Well, let's take a look at the picture. That means that this line right here cuts that angle in half. So then we get two small angles that are equal to each other. Angle 3 has to equal angle 4. So angle 3 and angle 4 are the same, so they're congruent. And hopefully you know by now, if you have a bisector, usually the next step is which two angles are the same, which is related to the definition of an angle bisector. And if you look at these two steps put together, that gives us a pair of angles. So now I've got two angles, two pairs of angles matched up. So I'm probably aiming now for 3 or 4. Okay, so let me draw a line here. This is kind of a second chunk of the proof. And notice the second chunk didn't depend on the first chunk. You could have put steps 4 and 5 right at the beginning of the proof, and that wouldn't really change anything. Okay, let's take a look at what else we can figure out. Let's say that we were aiming for ASA. Then the pair of sides that I need to match up would have to be touching both pairs of angles that I figured out. So it'd have to be the side in between the two angles. And if you look at this, here's one angle, here's the other angle, here's AB, right? Touching both those angles. Well, AB is the same in both triangles. It's reflexive. So step 6 here, I'm going to say AB is congruent to itself. That's reflexive. Right there. All right. So that gave me a pair of sides. Now, if you look at the proof, it looks kind of like I have AAS, but I don't really. These are 3 chunks of the proof that can be rearranged however I want to arrange them. So what I really have is, you got to look at the diagram. I've got this. I've got an angle, a side, and another angle, and the side is touching both angles. Whoops. So I actually have angle, side, angle here, right? And I have the same exact thing in the bottom triangle too. So now I can say triangle, if I call the first one, let's say BYA, let's say BYA, then you got to match up the letters in the second one the same way. BYA went 2 curves, no curve, right angle. So this one would have to go 2 curves, no curve, right angle, BZA. And the reason would actually be ASA, even though it looks like in the proof AAS. And now that I know that the triangles are exactly the same, I can match up any other parts that I want to that aren't already matched up. And BY and BZ are a couple of those parts. So I can say step 8, BY is congruent to BZ because corresponding parts of congruent triangles are congruent, or if you prefer, CPCTC. Just like that. Now, this is generally how these proofs work. The first pieces of the proof are trying to match up angles and sides, pairs of angles and sides. Then the next step is typically going to be matching up the 2 triangles that are actually congruent for whatever reason that works, one of these reasons up here. And then if there's another step, it's usually matching up other parts of the triangles now that you know they're the same, and using this idea right here to finish it off. Sometimes you then use that to prove something else, but we don't need to worry about that right now. Okay, let's look at 4. So 4 is just, they're kind of like doing these mini proofs here. So the goal is just to figure out, are the triangles congruent because of one of those 4 reasons that are listed here. So let's take a look at what we can do. So this one right here, we already have two sides matched up. We already have a pair of angles matched up right there. Probably the easiest thing to match up besides those would be these vertical angles right here. And if you do that, you have an angle, and a side that's only touching one of those two given angles. So so that would be angle, angle, side, or side, angle, angle. And then we would write, since that's a valid reason, that's this one right here, we can say triangle, let's say I call the first one ABE. Then what I've done is I've gone one curve, two curves, no curves. So this one would have to go DBC. And then you would say because of angle, angle, side, or side, angle, angle. Now, by the way, some students will see this differently. Some students might see this as, oh, look, these angles are the same, and they're alternate interiors. So they give me parallel lines. And then you can use those parallel lines to create this Z instead. And parallel lines give you alternate interior angles that are congruent. So now at this point, you've got this going on, which is actually angle, side, angle. So you could have also done it as angle, side, angle. Okay, let's take a look at B. So in B, we've got these angles matched up, these sides matched up, and the only other thing I can think of to match up would be these vertical angles. And so if you look at what you have an angle, a side, and another angle, and the sides in between the two angles. So that's ASA. So if I call the first triangle, which is a valid reason right there. So if I call the first triangle like FJI, and I want to match up the other parts of the triangle, that would have to go GJH. And those are congruent because of ASA. All right. The next one, we've matched up three angles in the first triangle, three angles in the second one. But that's all we've matched up. We can't match up. We don't know for sure that this side and this side are the same length. We don't know if any of the sides are the same length. So this one, all we have is AAA, which isn't one of our four reasons up here. So this one we would have to write, no congruence can be determined. Right, only have AAA. It turns out that's enough to say that they're similar triangles, but not enough to say that they're exactly the same size. Okay, and then D, let's see, what do we have in D? We have these angles matched up. We got a right angle here, which makes this one have to be a right angle there. You could match up, let's see, you could match up this side right here because that's reflexive. Whoops. But if you actually look at the diagram, over here, that side is only touching one of these two angles that we know. So we have angle, angle, side. Over here, you actually have the side in between the two angles that we know. It's angle, side, angle. These aren't the same. So this one would be no congruence can be determined because we have angle, angle, side orientation for the first triangle, but we have something different for the second triangle. And they'd have to be identical if you want to prove congruence. Okay, so I hope that helps a little bit, and I'll